Hello everyone, welcome back to our channel Problematical. We were discussing examples from chapter 1 sets, class 11th maths NCERT. Example 21st. Let U be a set of all the students in class 11th of a co-educational school and A be a set of all girls in class 11th. Find A complement. So, if you are to find A complement, then A complement will be equal to U minus A. Now, in a class, you can either have girls or boys. So, considering it as a co-educational, the standard typical co-educational school, A dash is U minus A. A is a set of all girls. Therefore, U is set of all students. If you remove all the girls from students, you will be left with A dash, which is set of all the boys in class 11th. Next, U is a set of 1 to 6 elements. A and B are given. You have to find these values. So first A dash. A dash is equals to U minus A. So 1, 2, 3, 4, 5, 6. And you have to subtract 2 and 3 from it. So you'll be left with 1, 4, 5, 6. Next, B dash. B dash is U minus B. From the elements of U, you are subtracting 3, 4, 5. So you'll be left with 1, 2, and 6. A dash intersection B dash. That means this value intersection this value. What is common in this? You have 1 and 6, two values which are common. Next, A union B. So A union B would be uniting the values of A and B, which is 2, 3 is common, so written once, 4 and 5. And hence show that A union B complement is equals to A complement intersection B complement. You've already calculated A complement intersection B complement, and A union B is available with you. So A union B whole complement would be equals to U minus A union B value. So from a universal set, you're supposed to subtract these 2, 3, 4, 5 values, and you'll be left with two values, 1 and 6. This is your 2, because this is the value of A union B whole complement. From 1 and 2, we can say that the right hand side is equal, therefore left hand side will also be equal. A dash, A union B whole dash is equals to A dash intersection B dash. This is from A and B, from 1 and 2. Next, if X and Y are two sets such that X union Y is equals to has 50 elements, so number of elements of X union Y is equals to 50. X has 28 elements, that means number of elements in X is equals to 28. Y has 32 elements, number of elements in Y is equals to 32. How many elements does X intersection Y has? So number of elements X intersection Y is question mark. Here we have a formula which links all these four values. Number of elements in X union Y is equals to number of elements in X plus number of elements in Y minus number of elements in X intersection Y. So placing the values, we have 50 is equals to 28 plus 32 minus number of elements in X intersection Y. Taking this on the left hand side, this on the right hand side, and calculating this, we have n of X intersection Y is equals to 60 minus 50, which is equals to 10. So 10 is your answer. Next, in a school, there are 20 teachers who teach maths and physics. So it's written that 20 teachers teach maths and physics. Who teach? That means you are supposed to consider that all the teachers teach one of the two subjects, which means number of teachers who teach maths and physics, considering P as a set of teachers teaching maths and M as a set of teachers teaching maths and P as a set of teachers teaching physics. This value is given to be 20. Of these, 12 teach maths. So number of elements who teach maths will be 12, and 4 teach both physics and maths. Number of teachers who teach both maths and physics means M intersection P. This value will be equal to 4. How many teach physics? You have to calculate number of teachers who teach physics. Again, putting it into the formula, N of M P union P is equals to number of M plus number of P minus number of M intersection P. Placing the values, we have 20 is equals to 12 plus number of teachers who teach physics minus 4. 12 minus 4 is 8. 8 on the left hand side, it will give you minus 8. 20 minus 8 is 12. So number of teachers who teach physics will also be 12, or 12 teachers teach physics. Next. In a class of 35 students, 24 like to play cricket, 16 like to play football. Now, in a class, it's written that in a class, that means all the students are either playing cricket or playing football. So number of students who play cricket as well as football will be equal to 35. 24 play cricket, so number of students who play cricket is equal to 24. 16 like to play football, number of students who play football is equal to 16. Also, each student likes to play at least one of the two games. This is another clarification for the fact that whatever total number of students are given are partaking in either of the two sports, which means your C union F is equals to 35 number of. How many students like to play both? Whenever you have the word both, dash and dash, then you are given with C intersection F. The intersection value is given to you, is supposed to be calculated over here. Putting it in the formula, N of C union F is equals to N of C plus N of F minus N of C intersection F. This is 35 is equals to 24 plus 16 minus number of C intersection F. Calculating this, we get 40 is equals to 35 minus N of C intersection F. This goes left, this goes right, and you're left with number of C intersection F is equals to 5. So 5 students like to play both cricket and football. In a survey of 400 students in a school, 100 were listed as taking apple juice, 150 as taking orange juice, 75 were listed as taking both apple as well as orange juice. How many students were taking neither? Now, what you're supposed to calculate is neither. That means there are some students out of these 4 students who are not consuming either of the two ingredients, either of the two juices, which means this 400 is now the number of universal set. It's not a number of A union O or A union B. Let A be the number of students who take apple juice and B be the number of students who take orange juice. Therefore, 100 are listed as taking people who take apple juice. So number of A is equals to 100. 150 is number of B. 75 as both. So 75 as students who take both orange juice and apple juice. You have to find those number of students who take neither. If you draw it in the form of a set, in the form of a Venn diagram, this region is A intersection B. This region is A union B, and the outside region would be the region where people or students do not drink. The green dotted region would be the region where students do not consume either of the two drinks. This is your A, B, this is U. Your orange part is A intersection B, and your yellow part is A union B. So by observation, we can see that to get this green portion, that means students who are consuming neither of the two juices, you first have to calculate A union B, and then you have to subtract the A union B from the universal set. Now, if you subtract anything from the universal set, you are calculating A union B complement over here. Either way, first you have to get the value of A union B. We know the formula for A union B is number of elements in A plus number of elements in B minus number of elements in A intersection B. So placing the values, you have 100 plus 150 minus 75. So this is equals to 250 minus 75. This is equals to 175. This is number of elements in A union B, the yellow portion, shaded portion. To get to the green portion, you have to find U, or students who take neither orange juice nor apple juice. This would be A union B full complement, which is U minus N of A union B. Now, N of U is equals to 400. You have to subtract 175 from it, and you'll be left with 225, which is your answer. Next. There are 200 individuals with skin disorders. 120 have been exposed to chemical C, 50 to chemical C1, 50 to chemical C2, 30 to chemical C1 and C2, both. Find the number of individuals exposed to chemical C1 but not chemical C2, chemical C2 but not C1, and then C1 or C2. So now, what is given to you? You're given that 200 individuals with skin disorders and 120 have been exposed to chemical, which means if you have a skin disorder, there might be people who have skin disorder, but C1 and C2 chemicals are not the reasons for it. Also, it hasn't been mentioned that all the individuals have either of the two, are exposed to either of the two chemicals anywhere in the question. So here also we'd have to consider this 200 as a set of universal set initially. Next, what is given to you? Number of people who have been exposed to chemical C1, let the set be A. So N of A is equals to 120 and N of B is equals to 50. Both means N of A intersection B. This is equals to 30. Exposed to both chemicals C1 and C2. Let's calculate N of A union B. N of A union B would be, do we need to calculate A union B? Given that you have to calculate chemical C1 or C2. Whenever you have an OR, you have to find out the value of A union B. That's why we are calculating the third part first. N of A union B. N of A plus N of B minus N of A intersection B. This is 120 plus 50 minus 30. This is 120 plus 20, which is equals to 140. N of A union B. Next, in your first part, you have to calculate individuals exposed to C1 but not C2. Exposed to C1 but not C2. This is C1 A intersection B dash. What does this mean? A intersection B dash. Another way of writing the same is N of A minus B, because we know that A minus B is A intersection B dash. Now, word-to-word translation will be chemical C1, but not as and, but means and यहाँ पर not C2 is C2 dash. That would be translation of word-to-word statements into mathematical form. We know that for this, A, the whole set A can be formed by uniting A minus B with A intersection B. In terms of numbers, we can write this: number of elements in A will be number of elements in A minus B plus number of elements in A intersection B. We know that union is plus and in words it is or. So number of elements in A minus B can easily be written as number of elements in A minus number of elements in A intersection B. Using this particular formula, we'll write here N of A minus N of A intersection B. N of A is given 120 minus A intersection B is 30, which is equals to 90. So there are 90 people who are exposed to C1 but not C2. Next. Second, individuals exposed to C2 but not C1. So N of B intersection A dash, or it can be written as N of B minus A. Similarly, B minus A can be written as N of B minus N of B intersection A. N of B is given to you as 50, and B intersection A is equals to A intersection B because it shows commutative property, follows commutative property. So this is 30, since N of B intersection A is equals to N of A intersection B, which is equals to 30, given. This is equals to 20. So there are 20 individuals who are exposed to C2 but not C1. This concludes your solved examples of this chapter. Now miscellaneous examples are still left that we'll cover in the next section. Thank you.